Transformations. So we're going to learn about two transformations this year, translations and reflections. In general, a transformation is moving a shape in some way. It's going to change the size, change the position, or change its orientation. All right, so size obviously means it's getting bigger or smaller. Position means it's just going to move across somewhere, either up or down, left or right. And then orientation means it's going to flip around or rotate in some way. It's going to change the direction that it's facing. So it's going to change in one of these ways. Actually, we're not even really going to deal with size changes. That was last year. You dealt with dilations. A change in position is going to happen with a translation and with a reflection. A translation is not going to change its orientation. It's going to look exactly the same, but a reflection will change its orientation. It's going to flip around. When we're dealing with transformation, we have an original shape. In this case, that's that bright green one. That's called the pre-image. And that flips over this line. That's a reflection. That becomes that image. So the pre-image, pre means before. That's the starting shape. Image is after we perform the transformation. The pre-image becomes the image. The points are labeled as B, A, and C. After the transformation, they're still the same letters, but now we have that apostrophe on them. We say that as prime. So this becomes A prime, B becomes B prime, C becomes C prime. We say the word prime to read that apostrophe symbol. When you perform two transformations, sometimes you'll add another apostrophe. So you might say C double prime. You might see two apostrophes. That's going to happen a little bit later in our notes. All right, let's get into the first one, a translation. Translation is a slide from one location to another. We're just sliding it across the graph. Horizontally means left and right. Think about the horizon. If you look out at the ocean, you see the horizon. That goes from left to right. That's that flat line that you see out in the distance. That goes from left to right. Vertically, that means up and down. If you like football, the vertical at the NFL Combine, that tells how high a rookie can jump. That's going up and down, seeing how high they can jump. So horizontally is left and right. That number is telling us how far to move left and right. Vertically, that's telling us how far to move up and down. Horizontally negative means we're going to the left 8. Vertically positive means we're going up 4. So we're really just going to count from each of these spots. We're going to count that out. -8 horizontally means 1, 2, 3, 4, 5, 6, 7, 8 to the left. And then vertically 4, so from there up 1, 2, 3, 4. The order really doesn't matter. We could also just go up 4 and then to the left 8. That is where P prime ends up. That spot is -5, +4. We always say the x coordinate first. That's -5. The y coordinate there is +4. Q, we're going to do the exact same thing. 8 to the left. 1, 2, 3, 4, 5, 6, 7, 8. And then 4, 1, 2, 3, 4 up. So that ends up at -2, -2. And you can see this line segment doesn't change at all. It's the exact same thing. All it did was slide over 8 and up 4. I'm going to do this exact same thing on this triangle. We're going to take each of these 3 points and follow this rule. Horizontally, 6. That's to the right 6. Vertically, -1. That means we're going to go down 1. So we're going to count each of these points. 6 to the right. 1, 2, 3, 4, 5, 6. And then down 1. Vertically, -1 means we go down 1 spot. 1, 2, 3, 4, 5, 6. Down 1. 1, 2, 3, 4, 5, 6. Oops, down 1. So that's G prime. That's F prime. Again, you can see it's the exact same shape. That triangle didn't change at all. All that happened was it just slid across. E is now at -2, -2. F is at 6, 1. G is at 3, negative 9. I'm going to do 3 more of these, even though that feels like that's too much. Really, all it is counting. As long as you understand what horizontally means and vertically means, you're just counting. Horizontally is left and right. If it's a negative, that means we're going to the left. Vertically is up and down. If it's negative, that means we're going down. So we're going to take all 3 of these points and go 1 to the left, and then 1, 2, 3, 4, 5, down to there. That's the new spot for D. So D prime is at 0, negative 4. F is over 1, down 5. That's 1, 0. And then E is over 1, down 5. That is 4, negative 3. You can see each of these is marked with a second apostrophe. It's really just to distinguish between these two. Actually, usually that's going to mean we're going to take this shape and move it by that rule. In this case, I'm going to take the original shape and move it by that rule, just because actually it would move off the graph if I followed all 3 of these on the same shape. So I'm going to do horizontally negative 5, or left negative 5, and vertically positive 1 with this original shape. And I'm just marking it with the 2 apostrophes to distinguish between that shape. So horizontally negative 5, 1, 2, 3, 4, 5, and then vertically 1. 1, 2, 3, 4, 5, vertically 1. 1, 2, 3, 4, 5, vertically 1. Again, same exact triangle. All that happened was it slid across. Same triangle. This one slid down and across a little bit. All right, so D is now at negative 4, 2. We always read the x-coordinate first, then the y-coordinate. So we move left and right first. We didn't move left or right at all here. We're staying right on the y-axis, so that's at 0, 3. And then F is moving 3 to the left, 6 up, 3 to the left, 6 up. One more time. Taking this original shape, horizontally, negative 6. That means left 6. Vertically, negative 6. That means down 6. So I'm going to take each of these points. 1, 2, 3, 4, 5, 6. And then down 6. 1, 2, 3, 4, 5, 6. Down 6. It's also pretty easy to just use the numbers. I know if that's starting out at 1 and it's going down 6, it's going to end up at negative 5. This one's starting out at 2. The y value is 2. So it's going to drop down to negative 4. This y value is 5. So I know it's going to drop down to negative 1. And the x value is 2. So I know it's going to go over 6 spots to negative 4. If you want to count, again, you can just count. But you can also think about that as subtracting. And I kind of want you to think about it like this, because in the next step, we're going to just use numbers rather than a graph. I'm going to record these coordinates real quick and show you what I mean. D is at negative 5, negative 5. E is at negative 1, negative 4. F is at negative 4, negative 1. All right, so really what I want to show right here is that these coordinates moved by these numbers, not just on the graph, but numerically, going from this original point. Let's look at F. Going from 2, 5. We started at 2, 5. That's the original point F. Oh my goodness, sorry, that's F. So F went from 2, 5 down to negative 4, negative 1. And you can see why that happened. Horizontally affects our x direction. That affects this first number. That went down 6. Vertically affects the y direction. That went down 6. Same kind of things happening here. This one started at 2, 5 still. Horizontally, down 5 means we're subtracting that 5. That ends up at negative 3. Vertically positive 1, we're just adding 1. So this affects the x, this affects the y, and it just affects each of those coordinates the same way. The same thing that we're doing as for counting, you're just applying that to the coordinates. That's what this question is asking about. We're going to write the coordinates of this point, A, after each of these transformations. If you'd like to, you can graph this. That is more work than you need to do, though. I wouldn't be graphing these. I would think about horizontally as the number that affects my x, and vertically, that's the number that affects your y. So horizontally, that's going to change this x value, and it's going to just reduce it by 4. Vertically, that's affecting the y value, and it's going to reduce it by 10. That gives us 0 and negative 7. If you were to count, that means we're moving 4 to the left, down 10. But you can also just directly apply it to these coordinates as a number. Vertically, negative 2. It doesn't say anything about the horizontal, so it means we're not affecting that x value at all. We're going to keep 4 the same. We're just going vertically negative 2, which means we're going to affect the y coordinate. That's going to go down by 2. So it's going to go down to 1. 3 minus 2 is really the operation that you're doing. Translate a point horizontally. That means we're affecting the x coordinate. So we're only changing the x. The y is going to stay the same. It's still going to stay as 3. Horizontally, negative 2. That x value is going to go down by 2, down to 2. I also want to think about this going backwards. Like if they tell us the transformation that happened here, going from these coordinates to these coordinates, we want to think about what had to have happened, and then just write that as a rule. So we're going to say something happened horizontally, something happened vertically. We're just going to describe what happened. The same exact thing is going to happen for each of these coordinates. You don't actually need all of them. Going from 5 to 3, we're going down by 2. 4 to 2, we're still going down by 2. 2 to 0, we're going down by 2. So horizontally, we're going down by 2. Vertically, 2 up to 5, 1 up to 4, 4 up to 7. Every time, all we're doing is adding 3. 5 plus 3 takes us up to 8. So each time, we're adding 3 vertically. Remember, this affects your x, this affects your y. All right, now we're going to use that picture to write a rule. So we know that this has to be the original shape. These don't have the apostrophes, those ones do. So this is our image, this is our pre-image. So we're starting here, and we're ending up there. You don't need all of these points. I'm just going to count from C to C prime. I want to say horizontally what's going to happen, and then vertically what's going to happen. All right, so from C to C prime, I'm moving 1, 2, 3, 4, 5, 6 to the left. 6 to the left is a negative 6 horizontally. And then 1, 2, 3, 4. Whoops, no, I counted that wrong. That's just 3. 1, 2, 3. 3 up. Vertically positive 3. All right, on this last one, this rectangle was moved to the image. This is our pre-image. This is our image. So something happened to each of these coordinates to take them to these new coordinates. So we want to think about what's happening here and then apply that same thing to P. And we're going to work backwards to where A must have started. So we're given the image for A, that's A prime. We want to find out the pre-image, where it started. So I just want to think about what happened for each of these coordinates. So going from negative 3 to negative 1. That's going up by 2. That same thing is going to happen here. We're just going to go up by 2. That goes up to 3. The opposite has to happen here. We're going to go down by 2. That's back down to 1. For the y coordinate, going from 2 to 1, that's going down by 1. Same exact thing has to happen here. We have to go down by 1. That's got to go down to a positive 1. This is going to be the opposite. We know we have to have gone down by 1 to get there. So we're going to go backwards. We're going to go up 1, up to a negative 1. All right, next we're going to talk about reflections. So a translation is sliding it across the graph. A reflection is a mirror image. So when you look in a mirror, you see your reflection. That's exactly what this is. It's going to be the exact same distance away. When you look at a mirror, if you're 5 feet away from that mirror, you're going to look like you're 5 feet away, just on the opposite side of that mirror. That's exactly what these reflections are. You have to decide what line are we reflecting over. So here we're saying we're reflecting over the x-axis. Second one, we're going to reflect over the y-axis. You have to decide which one we're reflecting over. And then you just jump over that line. However far it was away to start, it's going to stay that same distance away. Just end up on the opposite side. It's going to flip over that line. So we're jumping over the x-axis. That's the x-axis. P is going to jump over the x-axis. Right now, it's 1, 2, 3, 4 above. It's still going to be 4 above, 4 away, but now it's going to be 4 below. 1, 2, 3, 4 below. It jumps directly over the line and ends up the same distance away. So P ended up at 5, negative 4. On the second one, we're reflecting over the y-axis. This is the y-axis. So it's going to jump over that line. It's going to end up on the opposite side. It's jumping over the y-axis. It's right now 5 away. 1, 2, 3, 4, 5. It's going to end up 1, 2, 3, 4, 5 away on the other side. So that's negative 5, positive 4. All right, and these last two here, we're taking the entire shape and reflecting it over one of these axes. Actually, we're reflecting over the y-axis on both of them. It really just means you have to do it twice, or in a triangle's case, 3 times. You're going to take each of these points and jump over the y-axis. That's our y-axis. It's going to jump over this line. So right now, P is 1, 2, 3 away. It's still going to be 3 away, just on the other side. That's the new spot for P. That's negative 3, 0. Q is 1, 2, 3, 4, 5, 6 away. It's still going to be 6 away, but now on the other side. This is what I mean by change. It's not really a straight line. This is what I mean by change in orientation. It's the same shape. It didn't really change size. Didn't change what it looked like, but it changes the direction that it's facing. Instead of going that direction, it's now going that direction. That's the change in orientation. So Q is at negative 6, negative 6. All right, we're reflecting this over the y-axis again. Our y-axis is this one. People get confused a lot of the time because they think the y, that's up and down. So it should move up and down. But it's really reflecting over that line, so it actually moves the opposite direction. It moves left and right. Point F is already on the y-axis. It's just going to pivot on that spot. If you touch a mirror, it looks like you're touching your own hand. It's going to stay at that exact spot. That is the point for F prime. That is 0, 2. E jumps all the way across. It's jumping over the y-axis. Right now it's 8 to the left. It's going to end up 8 to the right. G is 3 away. It's still going to be 3 away, just on the other side. So G ended up at 3, negative 8. E ended up at 8, negative 1. Do a couple more of these together. I especially want to get to things where we combine different transformations. I'm going to quickly do these 3. That's just 1 point jumping over an axis. Point B is reflecting over the x-axis. That's our x-axis. Point B is jumping over the x-axis. Right now, it's 5 spots above. It's jumping over, ending up on the other side, 5 spots below. That's negative 5, negative 5. F is going to jump over the y-axis. That's our y-axis. It's 2 away. It's still going to be 2 away, but now on the other side. So that's at negative 2, negative 6. A is jumping over the x-axis. A is going to jump over the x-axis. It's going to end up on the other side of the x-axis. Right now it's at the top of the graph. It's going to end up at the bottom of the graph. A ends up there. All right, point E, we're going to reflect over the x-axis and then over the y-axis. So we're doing two things with point E. It's going to jump over the x-axis first. So it has to jump over the x-axis, jump up there. 1, 2, 3, 4. 1, 2, 3, 4. It's going to end up there after the first step. Then we're going to take that point and reflect it over the y-axis. So now we're taking this point, and it's going to jump over the y-axis. 1, 2, 3. 1, 2, 3. That's our final spot for E. That's -3, +4. I'm going to do one more of these with you just because I want to show you what a whole shape looks like when it's reflected twice. I'm going to do the second one. I'm taking this entire trapezoid here, that shape there, and reflect it over the y-axis, then reflect it over the x-axis. I'm going to do both of those two things. We're going to reflect over the y. That's this one. So it's going to look like it's going to act like a door. It's going to just swing on this line. W and Q don't move. They're reflecting over a line that they're already on. They don't move at all. L jumps to the opposite side. K jumps to the opposite side. W doesn't move. Q doesn't move. That stays right there. L ends up there. K ends up here. So you can see it's the exact same shape, just flipped. That's jumping over the y-axis. Now we're going to take that new shape and reflect it over the x-axis. So now it's going to jump over this line. All four of these points are going to flip over. It's going to end up upside down, jumping over the x-axis. So Q is at the bottom of the graph. It's going to end up at the top. W is 1, 2, 3 away from the line that we want to jump over. It's still going to be 3 away, just on the other side. And you can notice it's the same exact size. This is 2 right now. It's still going to be 2. W's there. Q's there. Actually, let's call that double prime. These are the original. That's the image after the first one. We're going to say this is the second image. So that's Q double prime. W double prime. L is 2 away. Still 2 away. K is at the top. K double prime. L double prime. We're looking for where does L end up. That's that point. So that's -4, 2. So just take that one step at a time, one point at a time. Take each point, count it out, think about where it ends up after each of those steps.